So we have the pH scale. pH of 7 is the middle. If we're saying pH here on the bottom, right? Now, if we go down, we're saying something is acidic, right? So we're saying this is the acidic side, and this is the basic side. Now, what makes something acidic? Well, if we keep going down this way, if we remember what pH stands for, right? pH is equal to the negative log of what? H plus or hydronium concentration, right? So that's what that means, which means we can change this to hydronium concentration, right? So if we remember that pH is equal to this, we can isolate hydronium concentration by taking 10 to the negative of that to give us our hydronium concentration. So if we have a pH, you take 10 to the negative of that to give you hydronium concentration, because if you do the math, get rid of that log, if you wanted to solve for hydronium concentration, you would take 10 to the negative of that to cancel this log, and this will fall down, or actually it goes in front of it. And then that gives you hydronium concentration. Right. Okay, so that means if you do 10 to the negative 7, you get 1.0 times 10 to the negative 7. And that looks familiar, right? If we say hydronium concentration is this, we remember our Kw is equal to hydronium times hydroxide. It means that we have this much hydroxide in this case, hydronium, excuse me, but if we remember it's a pH of 7, that means it's neutral, which simply means we have the same exact amount of both. So we have 1.0 times 10 to the negative 7 of both. If we draw a pOH scale right on top of that, 7 pOH, both of them have 1.0 times 10 to the negative 7. Here's OH concentration on the top. Now if we go down in pH, what does that mean? Are we going up in acidity or are we going down? Going up, which means we are increasing hydronium concentration. So you go this direction, we're getting to eventually 10 to the 0, which is 1. And if you take the negative log of 1, you get 0. Okay, I don't know if you're following me on that. That's why pH of 0 is 0, because essentially we have a 1 whole molar of hydronium in a certain container. Now I'm going really quick over this. That means if I go this way, I'm decreasing in hydronium, which means on this side, all it is hydronium is in greater concentration than hydroxide. And on this side, hydronium is in less concentration than hydroxide. That's all acidity and basicity is. It's derived in this idea, this inverse relationship of hydronium compared to hydroxide. That's why Kw we can use. And I'm not going to go into more detail than that, but as you go up in hydronium, you go down in pH. But if you look at it in the opposite perspective, you go up in hydronium concentration, you go down in pOH. Over here we have 14, and over here we have 0, right? This is 10 to the negative 14 OH. This is 10 to the 0 OH, which is 1. This is 10 to the negative 14 hydronium concentration. Really small, a lot of hydroxide. Really small amount of hydroxide, a whole bunch of hydronium. The two extremes, right in the middle, are the same.